Hello, everybody. Welcome to the webinar of Gausium, the Anatomy of Autonomy. Very joyful that you're all come here today. We waited a few minutes to let some people in. So I think now most people that want to join this webinar are inside, and let's start. So my name is Peter. I will introduce myself to you, Peter Questro. I'm the Global Strategic Marketing and Business Development Director of Gausium. And today I will be joined by our guest speaker, Dr. Baoxing Qin, the CTO of Gausium, and he will be sharing his insights and technical details with you today. So Baoxing, please say hi to the audience.
Hey, hello everyone. Thanks for attending this webinar. And it's my great pleasure to share with you our progress along the commercial cleaning robots.
Okay, thank you, Baoxing. So today's webinar, just to give a little bit, a head start, will be structured in two parts. First, Baoxing will talk you through the main topics in this presentation, and after that, we will move over to a live Q&A session. So I would say, Baoxing, the floor is all yours.
Okay, thank you. And for the first part of this webinar, I would like to introduce you Gausium. So who is Gausium? Gausium is world's #1 global leader in commercial cleaning robots. And so far, we have been delivering over 40,000 commercial cleaning robots globally in over 70 countries. And we have been doing our cleaning robots since 2013. Here is a brief history of Gausium. We were founded in 2013, and our first generation of commercial cleaning robots was launched in 2014. And all through the years, we have been launching new products. We launched our 75 in 2017, and we launched our Scrubber 50. We launched our famous products of Fantas at Interclean Amsterdam in 2022. And last year, we launched our latest generation of products, Mira and Marvel, at CMS Berlin. Here is an overview of Gausium's product portfolio. We know that cleaning is a universal requirement. We need cleaning in all the environments. So we look at the product portfolio from two different dimensions. The first dimension is the cleaning scenario, ranging from small to big. We have office room, office building, shopping mall, transportation hubs, and so on. And the second dimension is the cleaning functions. We need the robot to do the sweeping, mopping, scrubbing, and so on. So from these two dimensions, Gausium is trying to expand the product portfolio to meet the requirements in all the different vertical sectors. So we have Scrubber 75, we have Marvel, we have Omni, we have 40, we have Fantas, and all those different types of robots. And we will keep developing new products to cover the new different vertical sectors to meet the demands of different people. Here is our new product, the Mira. Mira is developed for middle-sized environments like middle-sized supermarkets. And the main function of Mira, it is 2-in-1. So it can do dry sweeping and scrubbing at the same time. It has a side brush and a roller brush to do the dry sweeping. It can clean the small debris. And we have the disc brush to do the wet scrubbing. And in this way, we can do professional sweeping and scrubbing in one shot. And what's more with Mira, it has the self-cleaning system for the dirty water tank. It can rinse its dirty water tank so that people don't have to do daily maintenance for the dirty water tank. With the same technology, we designed the twin brother of Mira. We call it Marvel. So Marvel is basically a bigger size version of Mira. It is designed for large warehouse and large supermarkets. What's different from Mira is its big side brush. We know that in a large industrial warehouse or in a large supermarket, we may have larger debris. And with a strong side brush, we can clean those large debris like paper, shred, and so on. And also we have the disc brush to do the heavy-duty scrubbing. Also, Mira comes with self-cleaning system. Marble comes with self-cleaning system inside. Okay, so since 2013, we have been developing all those type of cleaning robots. We have 75, we have 50, we have Fantas, we have Mira and Marble and so on. Looking into the future, what has been changing and what is going to be changed in the future. So let's take to answer this question, let's take a closer look at the 4 different dimensions of commercial cleaning robots, which is cleaning mode, intelligence, deployment, maintenance. We think these 4 dimensions are the most important 4 dimensions for commercial cleaning robots. And with these 4 dimensions, we divide this commercial cleaning robots evolution into 3 different stages: the basic stage, the autonomous and intelligent cleaning stage, and the 3D space cleaning stage. Back to 10 years ago, when we first launched our commercial cleaning scrubbers, we only have one single mode, which is scrubbing. And at that time, we have no online path planning, or we have very limited path planning. The robots mainly follow the predefined path to do its job. And also, to make sure the robot is safe, we have to draw a lot of watcher wall so that the robot doesn't go to dangerous areas. And also, in the very beginning, the robot doesn't really have a workstation. It relies on human to do the manual charging, to refill the water. And also, we have a lot of hassle to do the daily maintenance for the roller brush, for the dirty water tank, and so on. But now it comes to the new generation of products. With Mira and Marble, we are able to have multiple cleaning modes integrated into one machine. And also, the robot is equipped with better intelligence. It can do autonomous object recognition. It can do better online decision making, and it can also do intelligent cleaning. For the deployment method, we come up with remote deployment and also certain type of zero or light deployment to support out-of-box usability. Here, when I talk about zero or light deployment, I mean we don't really need to do any deployment, or we only need to do very little deployment. And for the maintenance part, with the help of workstation, we can do automatic charging, refilling, and also with the help of the self-rinsing system, you can do self-cleaning with the docking station. And moving forward, we are also looking into putting robotic arm onto the mobile base, so that we are no longer limited to 2D floor cleaning, but we can extend the scope into 3D space. We can do cleaning for the vertical surface like the glass wall. We can clean the toilet and so on. So to sum up, we think the most important features for the new generation of robots are fourfold. First is cleaning modes. We need to have multiple modes integrated. For the deployment of the new generation of robots, we need to support remote deployment or light or zero deployment. And for the maintenance, we need to help the human out. We need to have certain type of self-cleaning for the robots. And for the intelligence, we need to have a better understanding of the environment. We need to have a better decision-making. And the robot need to have certain type of intelligent cleaning capability. Now, let's take a look at our work along these different dimensions. So first is with remote deployment. Right now, when we are talking about deployment, deployment work is usually done by professional engineers. But when we want to deploy hundreds or thousands of robots at a batch, we don't have so many professional engineers on site. Is there any way we can bypass or go around this issue. So here we come up with the idea of remote deployment. With remote deployment, we can lower the deployment cost. We can deploy robot at the batch. So the idea is, instead of using professional engineer to do the mapping and map editing on site, we ask the janitors or the cleaners to do the mapping. The cleaner just need to push the robot around environment, and the robot can do the mapping by itself. After that, the robot will upload all the data to the cloud, and we can build a 3D model of the environment with a LiDAR point cloud and also with the camera mounted on the robot. Then the engineer from the backend can do the map editing, and according to the color and the point cloud from the 3D map, and also they can do the to draw the path to set the tasks in a remote way. So in this manner, we separate the mapping process and the map editing process so that we can do the deployment at a batch. So this is our idea of remote deployment. But is there any way we can do better? Yes, of course. We are thinking to do a mode called drop and go. So here is a video about me introducing drop and go at the ISSA show last year. So the idea is, imagine we are inside a ever-changing environment like a ballroom. We have the chair and table moving all the time. You cannot rely on a static map to do the tasks. Is there any way we can do cleaning in such an environment? So we introduce the idea of drop and go. It can do the mapping and cleaning at the same time. So we have one button on the robot. By clicking it, the robot will start the drop and go mode. The robot will first explore the boundary of the environment and perform edge cleaning at the same time. Now the robot is trying to explore its boundary. And after the boundary exploration, the robot can find the outline of the environment, and the robot will do the rest of the coverage cleaning. After the robot performs the coverage cleaning, it will generate the task report together with the map, newly generated map. In this way, the robot can, without any deployment efforts, we can ask a robot to perform cleaning tasks in an ever-changing environment. So what's behind this remote deployment and drop and go mode? So it's actually our perception, 3D perception of the environment. From our product of Omni and the new product of Mira and Marble, and also future products, we will all equip our robots with 3D perception, including 3D LiDAR, 360 degree of LiDAR, and 360 degree of cameras, with the premium set of sensor suite. We can recognize all the surrounding environments. We can detect all the possible hazards so that the robot can navigate in the environment in a safe way. Beyond deployment, people are troubled with a lot of the maintenance work. We designed the cleaning robots to help people from the daily cleaning work, but now people are stuck in the daily maintenance work. People have to do the maintenance for the roller brush, for the side brush. People have to clean the dirty water tank. People have to clean the suction pipe to prevent it from stuck. So all those efforts are hassle. We are trying to remove human. Since we are trying to remove human from the loop, we need to find ways to mitigate these issues. And here is an example of Fantas doing self-cleaning for the dirty water tank, squeegee, and suction pipe. After the Phantas finishes its job, it will go back to the charging station. And automatically, it will do the battery charge, and it will refill the fresh water and let go the dirty water. Then we go to the self-cleaning mode. So the charging the workstation will add the clean water to the sink, and the suction pipe, the robot will suck the clean water through its squeegee and the suction pipe to the dirty water tank. And we do this type of self-cleaning for several rounds. Then the squeegee suction pipe together with the dirty water tank will be cleaned. With this way, we can save human from doing this daily maintenance for these parts. But we still have a lot of work to do. We need to find ways to clean the roller brush. We need to find ways to empty the trash bin by itself. So along all the way, we need to reduce the human efforts to minimum. So we still have a lot of work to do, but we are on this direction. And now let's talk about the intelligence. Intelligence is the most important part for the autonomous cleaning robots, together with the cleaning capability. So there are two folds of this intelligence. The first part is autonomous navigation. Since the robot is running in quite complex environments, it has to be able to localize itself. It has to be able to detect all the possible types of environment, and it has to be able to coordinate with human and cars. And besides that, the robot has to be able to recognize certain type of trash or stains. It has to be able to evaluate the cleanliness of the environment. So only with this capability, the robot is called the AI robot. And here we show our capability with Omni. So Omni can detect all these type of human vehicles, escalators, carpets, wire detection, billboard. As we know, it's never easy to cover all these long tail corner cases. But through as time goes by, we are able to recognize all of them. And the second part is with intelligent cleaning. Instead of doing traditional cleaning to cover all the areas, we ask the robot to detect the trash so that the robot can do on-spot cleaning. And through this way, we can maximize the cleaning efficiency by 4 times. After looking at the video, now let's take a hardcore view of what's intelligence and what's behind it. So actually, there are 3 core foundational elements for true AI. We call it algorithm, data, and computing power. It's a trio. And we take very serious about intelligence, and we try to make the most intelligent robots. For the algorithm part, we have been keeping learning from the autonomous driving industry, and we keep implementing the most advanced algorithm. And from there, we have the omnidirectional bird-eye view perception. We are able to detect over 100 semantic types of objects. And we developed the occupancy network, the generic object detection, so that we are safe for all types of objects. And we use the large visual model for high-level reasoning.
Excuse me.
This is our,
Sorry to interrupt you, Baoxing. Can you perhaps explain the audience what a LVM means for people that are on my level of understanding?
Yes. So LVM is short for Language Visual Model, which means which is the latest progress in AI field. So given a picture, the robot is able to tell what is inside the picture, what kind of scenario, and also what should the robot do.
Okay, that's very clear. Thank you. Thank you. Please continue.
Thank you, Peter. Yeah. So the second part is with the training data. So the training data is actually plays a very important role in intelligence. We are always kidding. The more data you have, the more intelligence you have. So data is a carrier of knowledge and is a carrier of intelligence. Luckily, Gaussian has the world's largest commercial cleaning robot fleet, and we have the luxury to have the world's largest commercial cleaning dataset. And for the industry standard, for each object recognition task, people use, let's say, 50K annotated data. But for Gaussian, we use more than 1 million annotated data for each task on average. For example, for the car parking scenario, we have been deploying over 3,000 robots in China in the car parking areas over the past 3 years. And we are able to collect all those data in China market and train our model. Due to certain GDPR issue and the data privacy issues, we are not allowed and we are not going to collect any data from overseas market. But since we have all the data from China market, we are able to collect data for all those diverse scenarios, train our model, validate our model. Once those models are validated in China market, we will upgrade the software for our overseas customer. So this is the data part. So the last part is about the computing power. So people have been arguing if it is necessary to have more computing power. Actually, our argument is you only need to have a certain type of computing power, but it's not the whole story. For Gaussian, our strategy is to develop streamlined edge computing via model distillation and network pruning. And to make our computing more efficient, we use one unified backbone for all tasks to achieve efficient and accurate detection results. And here, when I talk about one unified backbone, I'm mainly talking about we try to use all the data to train a unified model of the environment so that we can detect all those types of objects. Maybe I can give a metaphor. It's like a chef preparing dishes. And we can use 10 types of tools to make 10 types of dishes. But we can also use one type of powerful tool to make 10 dishes. In this way, we can cook in a fast manner, more efficient manner. And as a result, we are able to achieve 360-degree perception using only 6 tops. And for autonomous driving industry standard, people usually use 100 tops to achieve similar performance. Yeah, so here is the whole presentation, and thanks for your listening.
Okay, thank you very much, Baoxing. So let's go ahead with the next phase of this webinar. Let's look at the Q&A session. I think there will be some questions already sent by some of you. I'm trying to collect them right now, but there's a little network error. You always will see this, of course. Too many people are online at this moment. But here I see one. So here I have a question. Advanced technology compared with other brands. So this is from Jim. Okay, Jim, thank you. In case I need changes in the map after a while, how can you manage that without being on location?
Okay, so basically there are 2 questions. How can we compare to other brands? And so from our understanding, we have Gaussian has been pioneering the industry, and it's never an easy task. And luckily, we have a lot of other good companies who is also developing good products together with Gaussian. And the Gaussian strategy is we deploy most of the fleet. So we have the largest data set. And with the largest data set, we can develop the smartest algorithm. So this is our strategy number one. So strategy number two is we are keeping expanding our product portfolio. Gaussium has the most complete product portfolio to meet the customer requirements from all different sectors, whether it is in hotels, whether it's in transportation hubs, whether it is in industrial park. We all have the most suitable products to cater people's requirements. But up to now, there's no other company can offer such complete product portfolio. So this is my answer for the first question. And but luckily, I think together with other companies, we are making a better industry, and we can deliver better products. And for the second question is, we still need to do map changes, map editing after a while. So Gaussium has developed the map updating algorithm so that the underlying the Gaussian SLAM technology, we are able to update the maps by itself. And with the dynamic auto cover path planning, we are able to, so the robot is able to handle the changes in the environment. But of course, to a certain extent, if the environment changes too much, for example, the shelves or the let's say the furnitures all disappear, or it's a totally different world, the robot can still not able to handle those so far. But we are moving to better capability.
Wow, thank you. Very clear answers, Baoxing. I think this is very, very clear. In the meantime, I have another question from Daniel. He says, I see you have a very wide assortment in cleaning robots. Do they all have the same user interface?
Yes. So for our latest products, we all share the same software stack. But there's one exception. It's a Scrubber 75. It's a oldest generation of products. We keep it as its own. But for the rest of the products, we all share the same UI. We share the same algorithm. We share the same way of operation. In this way, we can develop better products in an efficient manner. And also, those different types of objects, they can share the data. So we can build a better algorithm altogether.
Okay, I think this is also very clear. And I think it's also very practical, to be honest, for operators in the field to have the same user interface. And in the meantime, I've got a question from Watson. How are your robots technically dealing with glass doors?
Oh, glass doors. Glass doors is a nightmare, actually. We have been trying different ways to deal with glass doors. So in the very beginning, people use ultrasonic to detect glass doors, but it's not 100% safe. And later on, we use deep learning to detect the glass door, which means when from the cameras, from human eyes, we are able to recognize the glass door, and we are able to recognize the boundary of the glass door with the floor. And from there, we know, oh, this is a dangerous area. You should not go there. But there are certain type of glass door that is hanging there. It's not touching the ground, and it's hard for the robot to tell the boundary. In this way, we use LiDAR. We use certain type of LiDAR to detect the glass door. And also, if the customer allow, we may stick some of the patterns onto the glass door. Let's say certain infrared stickers, so that the robot will be able to better recognize those glass doors. Yeah, there are several types of techniques, but only with the approval of customers, we can implement all those techniques.
Okay, thank you very much. I think we don't need any echolocation anymore for this, so this is very good to hear. In the meantime, I've got another question from Justin. This new robot called Mira Why doesn't it have a roller brush for scrubbing, but pads and disc brushes on the end?
Oh, okay. So this is a good question. So when from the cleaning industry, I must confess I'm not from the cleaning industry in the very beginning, but I learned a lot from the cleaning industry. So we know that roller brush, the advantage of roller brush is it can pick up the small debris while doing scrubbing. But the when it comes to scrubbing performance, we still prefer disc brush over roller brush because the area that the disc brush can touch the floor is bigger than roller brush, and you can have basically more time to do the floor cleaning with disc brush. So in a nutshell, disc brush has better scrubbing performance than roller brush.
Okay, thank you. Yes, I totally agree with you. I'm coming from the cleaning industry, and I could not have said it better than you do. So, in the meantime, I have a question from Andy. What is your biggest advantage in technology compared to other brands? That's a deep question.
Oh yeah, I think I've answered this question, but I can repeat myself. So first of all, we have the most complete product portfolio. So we have, as I've shown in the slides, we have robots ranging from small to big ones, and we are able to cover the cleaning requirements from different sectors. This is the first one. The second one is since we have the largest fleet, we have the biggest data set. And with the help of the biggest training data, we are able to develop the most accurate algorithm for object recognition. This is the number two. And for number three, we are keeping we are keeping developing new technology such as remote deployment, drop and go, and we are keeping borrowing the idea from autonomous driving industry to make the robot smarter. For example, we use the large language visual model to help the robot to better seeing understanding. Yeah.
Okay, thank you very much. Of course, when we go really in depth, I can't. An hour is not enough, but thank you very much. This is very clear. In the meantime, I have a question from Li Ming. He is asking, I saw the Marvel on LinkedIn. Is this your biggest robot, and does it replace the Scrubber 75? Actually, it's a good question.
Oh yeah, I think this is a very relevant question,
Yes.
and yes. So it's a tricky question though. So for now, Marvel is the biggest robot. We would like to have Marvel to replace Scrubber 75, and but in the future we are currently also developing even bigger products to cover even bigger areas. So this is my answer.
Okay. And I have here a question from one of the other sources from LinkedIn. I see now, and it's under us. If Gaussian and its two major competitors would start a trial period with the same customers and in the same facility, what performance metrics could set Gaussian apart? So what's the difference? So where can we distinguish ourselves? That's what I understand from the question.
Yeah. So this is a very good question. I think back to the slides, the four dimensions that I mentioned. The first is deployment, how fast we can deploy. If we can deploy the robots at a batch, whether we have this capability. So this is the metric number one. So metric number two is about intelligence. But from intelligence, what we can do is we can have come up with several metrics. Whether your robot get lost often, how often your robot get lost, or whether it even get lost. Second is what's the efficiency of your robots. Third one is what's the mean time between failure of your robots. So basically, how often do you have to ask human to intervene? So this is the number 2. So the dimension number 3 is about cleaning modes, whether you have the dry and wet cleaning in one go. So this is a clear difference. So for the fourth one is about the maintenance. How often do you have to ask your cleaners to do the daily maintenance? So I think from the 4 dimensions we just discussed, I think we can derive a set of metrics to answer these questions.
Okay, and I can add to that, you can see it in the practice, I would say, from my perspective. Okay. Oh, by the way, I see here a new question from Hans. I see you have your own chemicals for the robots. Why is this better than other products? I think I can perhaps better answer this question, as I was a project leader of this whole new chemical thing. Well, first of all, it's not actually a chemical. That's the nice part of it. It's a leaf, so it looks like a piece of paper. Only the base is based on seaweed cellulose. So it's water soluble. So when you put it into a detergent tank, you pour 2.3 liters of water on it, you're making actually a concentrate on the spot. So that's one of the biggest benefits. So you don't have to, send out cans and canisters full of liquid concentrates. And then the product is pH neutral, so it doesn't hurt the robot, and it also will not hurt the floor. But it doesn't mean it doesn't clean, because it cleans very, very strong. It also has some embeddedness that it can, clean the crouches by microbiotic traces that are inside. And it has some additives that can prevent for a bad smell, growing in your wastewater tank. So it has several advantages, and perhaps also one that's a little bit, flat, but it's also a big advantage. It will save you about 70% in cost in use. So it has a lot of ecologic, health, and economic, advantage, this product. And that's why we developed this one for the robots. So we can send it very easily in an envelope. I could send, 25 leaves and actually sending you almost 6,000 liters of cleaning solution. So that's why we think is a very good solution. I don't say that other products are not good, but the whole concept is totally different than all products you have ever seen on the market. Okay, well, let's continue here. I have here David. David has a question. Hello, everyone. For ceramic or marble floors, this robot is always scrubbing, right? Or does it also sweep, is his question. Well, I don't know which robot he is referring to. Shall you answer? Shall I answer?
Yeah, Peter, you can help answer this question.
Okay. So, of course, when you're talking about the new robots, I guess, the robots that we showed in the presentation, Mira and Marvel, they can indeed always sweep, and you can shut off the scrubbing if you want, yes or no. So on marble floors and ceramic floors, doesn't make a difference for the robot. If you're talking about chemicals, it absolutely is safe on this kind of floors. But you cannot shut off the sweeping part. So you can do the sweeping with the scrubbing in one pass, and you can shut off the scrubbing part. And of course, you can make a choice which kind of pads you want to use. If you have a marble floor, for example, you can use also diamond pads. And if you have a ceramic floor, you can use blue pads or green pads. So the pads that you think are best for your floor. This always depends, of course, on the kind of material, or the kind of the floor that you have. And sometimes a disc brush is better when you have deep crouches and joints. I hope this was the question, and I hope this is the answer is good. If not, please let us know, and we can come back to you more in detail. And in the meantime, I have a question from Fabio. He's asking, in some cases, we need the ability to let the robot drive in only one direction. Like one direction area. Is something like this planned? So he means, I think, that is when it's only one way, the robot cannot return in that way. Can we technically make it happen? Good question.
Yes, very good question. And yes, the answer is yes, we can make it happen. I can share with you about a scenario in car parking area. So there is actually direction for the lanes, and our robot is only allowed to follow the direction of the traffic so that it will be safer. And we planned our path to obey the traffic rule. So in this way, we can do the one direction planning. And I'm not sure whether I answered the question, but this is what we are doing.
Okay. Well, I guess we're almost running out of time. So I think we had some very good questions. It's a little bit more than 10. And if your question was not answered during this session, then you can always let us know. So we can ask you after the session. And so thank you very much for all the questions that you sent in to us. It's very learnful. And so we're going to wrap up this Q&A. And I want to have something very nice to be able to tell you, and that's that we are having a show in 22 to 26 of February in Düsseldorf in Germany on the Euro Shop. And of course, if you are able to come there, we would welcome you very, very, very much on our booth to see actually all the new robots and how they work. So you can see the real stuff. That's always better, of course, than a video or an animation film. So again, thank you very, very much for you to be here. And I think there's a last slide that we can show you with the QR code. So if you want to contact us, then please do so, or we leave this on a little while so you can take with your phone. You can scan the code and get in contact with us. And thank you very much, Baoxing, for your time and answering all the questions today. That's very learnful. I also learned some things today again, so that's always good. I always say we're learning every day, and I think that goes for all of us. So again, thank you very much, and hope to see you back in our next webinar, and or perhaps see you in the Düsseldorf Euro Shop in almost a week from now. Thank you and goodbye.
Thank you. Bye-bye.
Bye-bye.